Hey, hello and welcome. And thank you so much, all of you, for choosing to spend your lunch hour with us. Well, Neha and I are really excited to talk about how to protect your data environment from ransomware using Zero Trust on AWS. But first, a quick introduction. So my name is Nancy Wang. I'm the Director and General Manager for AWS Data Protection Services. And joining me on stage is Neha Rungta, who is our Head of and Director of IAM Automated Reasoning. Today, we're going to be covering a few topics, starting with why a Zero Trust architecture is so key to ransomware protection. Then we'll go into some of the really cool innovations that are coming out of our identity org around provable security and immutability with the Zero Trust architecture. Then we'll tie it together with a case study involving Amazon consumer payments. And then finally, we'll actually walk you through a self-guided managed solutions architecture of how you can protect your data with Zero Trust architecture on AWS. So let's start by talking about the nature of ransomware in the cloud. As ransomware has evolved from on-premises data centers to the cloud, it's also changed the nature in which attackers go after your data. So let's focus today's conversation on what is modern ransomware and what are the actors really going after. Right? So modern ransomware targets the C, the I, and the A of your data. Right? The ransomware actors aren't just encrypting your data anymore and asking for ransoms to de-encrypt your data. Instead, they're actually exfiltrating your data and sometimes asking to release that data if you don't give them additional sums of money. So with that said, this has become an important topic of paying ransoms aren't just enough anymore to get your data back. In fact, I want to point to two examples here. I'm sure all of us have heard of the Colonial Pipeline event as well as the JBS meat processing event. Well, I bring up those two examples because they're examples of companies who actually did end up paying the ransom amount to ransomware actors. However, they, as well as many other companies, have actually said that even by paying the ransom, they were not able to get 100% of their data back that they had prior to the event. As well as it took them weeks to bring their businesses back online, which means lots of downtime, loss of customer trust, and so many other implications. So with that said, don't rely on paying the ransom to get your data back. Let's start by creating a comprehensive data protection strategy utilizing Zero Trust architecture on CIA. All too often, the conversation around ransomware is all about, do you have the right IAM controls in place? But what if instead, you could actually know that all the paths to your data were in fact secured? Better yet, what if you could prove that your data and business were immune to common attack paths? So today, with the help of AWS Zero Trust best practices and our Provable Security framework, we're trying to show you how that you can achieve this goal of protecting your data on AWS. But first, let's talk about Zero Trust and how it applies to your environment in the AWS cloud. So I bring up this graphic because it's really about a mindset shift, right? Talking about intuition. Because from the lens of ransomware, if we assume that actors are already inside your environment, how do we make it really, really challenging for them to exploit you and to get to your core data? Neha, why don't you take it away with defining Zero Trust on AWS?
Thank you, Nancy. It's really great to be here and talk about one of my favorite topics on provable security and how to help ensure and protect your data. And coming to Zero Trust, we think about Zero Trust where it's like, hey, is it a binary choice between identity-centric controls and network-centric controls? And the real answer here is the identity-centric controls bring a lot. Like you have the SigV4 request signing, which is used to interact with the AWS API endpoints. And then we also have the network controls. We have such as VPC controls, AWS security groups, private link, and VPC endpoints. Each of these are straightforward to use and understand. And the answer is, it's not about either identity-centric controls or network-centric controls. It is about a combination of both of these. And ideally, these two controls should not only coexist, but they should be aware of each other and even augment each other. So for example, the one we have in AWS is called VPC endpoints, and they provide us the ability to attach a policy that allows you to write and enforce identity-centric controls and around a logical network boundary. And in that case, your private network exit from your VPC is essentially an only way out to a nearby AWS service. And now that we have these combinations, I'm going to actually go back to Nancy, where she's going to talk about how in this zero trust world, we have protections in AWS against ransomware.
Thank you, Neha. And a lot of what actually Neha will be covering in just a second around the cool innovations that's coming out, I want you all to keep this next 4 slides I'm going to go through about thinking of ransomware and how you can protect the confidentiality, the integrity, and the availability of your data than using Neha's innovations. So let's start about talking about what ransomware actors will actually go after, right? They'll typically go after the core data that powers your business, whether that's your databases, customer records, or your object network stores. So if we're going to protect yourself from ransomware, we need to start from your crown jewels and be able to work backwards from there. So what are those 4 steps? Right? They can be summarized as step 1, actually know where your crown jewels are within your environment. Right? So many of us with data sprawl and copying data so many different times, we end up having sensitive data that's all around in our environment. So knowing where it is, right? Going back to data visibility. Then once you know where your crown jewels and sensitive data lives in your environment, second step is to protect them, right? With the right configurations and policies that we'll illustrate with examples. Then harden all the paths to your crown jewels in your environment, and we'll actually go through some native AWS managed solutions that can help you do just that. And then finally, right, never discount a regular patching strategy. So step 1 is knowing where your sensitive data actually lives in your environment. One solution that I'd love to recommend is using Amazon Macie to classify your data and to detect where your crown jewels are in your environment. And once your data is classified, I also recommend to tag it properly to reflect its level of criticality to your business. For example, many businesses today conduct their BI experimentation in a data lake. So imagine a large data lake where many people are moving large amounts of data around and they're conducting experiments and building models. Right? That's a great use case to apply Amazon Macie to classify that data, then to apply tags, which I'll go through in the next slide, and using those tags on how to protect your data. So for each of your crown jewels and data stores, first off, verify that you have an appropriate backup cadence enabled. And an easy way to do that, as I covered in the last slide, is to use tags, and with tag-based backup policies. Especially since many of our workloads today are ephemeral, right? Think containers, applications, think serverless. Having an immutable backup copy or a golden copy ensures that you're able to recover your critical business data if you are ever subject to a ransomware event. One example of this could be, you have an S3 bucket that contains customer records that is readable and writable to and by a mission-critical service. Imagine that you did not have a backup cadence for that S3 bucket enabled, and let's say an external actor, think Log4Shell, which is a day 0 vulnerability for Log4j, starts encrypting your data in that bucket without your permission or knowledge, right? You're not going to have a backup copy to recover from. And so once you have backups enabled, also consider applying Vault Lock, which as of this reInvent, we're excited to announce that it has been certified to be SEC 17A compliant, FINRA compliant, as well as CFTC. And why that's so important is that many financial institutions today in the United States are regulated so that they can prove to auditors that their financial records are not being altered without their permission. And step 3, zero trust is all about explicit auth-N and auth-Z and not taking either for granted. Trust, but always verify. Once you've identified where your critical data lives within your environment and you have backups in place, make sure that you're properly authenticated and that also your authorizations are the right ones. Start by evaluating IAM and network paths to your data, and once identified, consider right-sizing them, think least privileged, to your data. Consider using IAM Access Analyzer, which can help you generate least privileged roles based on your CloudTrail logs. Ensure that all human access to critical systems goes through privileged access management, as well as an MFA token for authentication. And finally, ensure that systems-to-systems access goes through mutual TLS. And step 4, patching. Just want to reiterate that because it's such an important strategy among security professionals. In fact, they've ranked it top 3 among their strategies for protecting their environments from ransomware. However, with that said, the same study also showed that less than 50%, though, of respondents actually said that they did have a regular patching strategy in place. And why this is important is think back to the 27 WannaCry event, right, where the companies who were impacted by that vulnerability actually did not apply the patches that were released specific to that vulnerability. Right, so an example workflow that I have on the slide here is using AWS Systems Manager Patch Manager, which can do and conduct automatic baselines of your patching, as well as uses other managed AWS services, such as AWS Config, to actually help you audit and conduct compliance checks to make sure that you are, in fact, in compliance with the patching that you need to do for the critical servers that you've all identified. So I'm going to pass it to Neha, but I want to make sure that based on the 4 steps that we covered, as well as the mental framework and the intuition of thinking about modern-day ransomware in the cloud, is as she's going through the analytical capabilities that's coming out of her org in techniques of symbolic analysis, think about how they can be applied in your environment.
Thanks, Nancy. I think it's really important to start thinking about how are you going to protect the data and how much assurance you have in that your data is protected. And today I'm going to talk about provable security. To start off, I want to first build a mental model. And for that, let's think of code. Most of us write code, and when we do, we think about what it does, or at least what we want it to do. And to really help gain assurance in its correctness, there is a variety of techniques we apply to it. We apply unit testing, integration testing, canaries, we do code reviews, there's AppSec reviews for things that are security related. And more we do these activities, the more we have assurance in its correctness. And all of these activities are necessary, but they're not sufficient. And why? Because we want to know for certain critical things when it comes to the security of our data. We want to know all the possibilities, the universe of possibilities that our data is protected. And that is where provable security comes in. It allows us to make universal statements about the security of our data. So what is a universal statement? A universal statement has words such as all, every, each, always. So the counter of these, of a universal statement is a mostly correct statement. Most of my code is correct. Most of my buckets are secure. And that sounds sort of okay, but it's not certain. And that level of uncertainty is not what we want in modern day data security. So for a little piece of code, here's what the universe of possibilities may look like for just a small piece of code, not even very big. And each node here is a program statement, and an arrow between the 2 nodes is a way to move from one statement to another. And each path in this graph is a different way the code can execute. Now, there is an infinite number of paths because you can have loops in your code, and for each of the loops you would unroll them, and each unrolling would represent a path. And the details here don't really matter, but with a graph like that, what we want to know is, are all of these paths correct? Are they all intended? Are they all secure? Do any of these paths violate one of my universal statements? And wouldn't it be great if I could press a button, a single button, and find all the paths that violate a universal statement you want to make? A universal statement you may want to make is, here's an S3 bucket and there is no public access. Or you may even want to make a stronger statement. There is no public access to any of my resources. So as you can imagine, these are the types of statements where you want certainty. And this magic button is something that would search the entire universe, all the inputs, all the configurations, and do it quickly. So this is the focus of this talk. I'm going to talk about a case study that Nancy mentioned on how Amazon Consumer Payments is using some of these techniques to ensure the security of its data. And most of you are actually aware of what I'm going to talk about. It's just that the vocabulary is going to be a little different. And you'll still want to do the things you're doing, the testing, the fuzzing, the canaries, the integration testing. And together, while they don't cover the universe, it gets you to the point. But provable security is the next phase for really ensuring the security of your data. It's the use of mathematical techniques to prove your data is indeed secure. And the first thing to understand, I'm really excited about this case study that we worked in tandem in Amazon Consumer Payments, who are an AWS customer like you. And they haven't always been. That's what makes this very exciting. So let's take a look on how they got to be an AWS customer. Consumer Payments is essentially responsible for securing payment critical data for all Amazon customers. It means that they have credit card numbers, bank account numbers, billing addresses on hundreds and millions of AWS customers spread across the globe. And in the past, they've kept this information secure on a custom on-prem isolated environment called the Payment Secure Zone. It was expensive to build and expensive to operate. It wasn't air-gapped, but it was as close to air-gapped as possible. And the servers were kept in cages, separate from the rest of the Amazon data center. The operators needed to physically drive to the data center if they wanted to do a software upgrade. In fact, Amazon rented out like year-end lodging near the Payment Secure Zone so the operators could physically be there in case of an emergency. And over the past few years, Consumer Payments has been migrating this environment to AWS in a project called Lumos. And going from this nearly air-gapped on-prem system to cloud-based, they wanted the same level of assurance in the cloud as they had in the Payment Secure Zone. And for that, they've been investing in using Provable Security, which I'm going to tell you more about, and how their security of the data in the cloud is helping them. So here's how Lumos fits into the broader Amazon ecosystem. So when you put in your credit card into the Amazon website, it's encrypted with HTTPS and sent to an Amazon web server. That server re-encrypts your credit card number with a key that only Lumos can decrypt. The encrypted value is sent to Lumos. Then they've securely stored your payment information, but now how to use it? For example, Lumos generates an opaque random token and associates this with your information. So now this token is sent to other Amazon payment services. Since the token has no meaning outside of Lumos, they don't need to be paranoid about it. Even if an attacker gets a hold of the token, they won't be able to do anything with it without an external meaning. So, but now what happens if they click buy now? Here, you have to send they have to send a payment request to a partner bank. So there, it's a payment request token is generated and sent to Lumos, which then encrypts this payment request token with the data and sends it to the partner banks. Now, if you want to know more about the internals of Lumos or what's going on in the pink box, it's like how is the payment information actually stored and protected. There is a reInvent 2021 talk, and just search for Lumos and reInvent and you'll find it. But this is just a high level architecture of Lumos to set up how they're using Provable Security. So the universal statement that Lumos is targeting is about customer data. And I've already said they're responsible for payment critical data for hundreds and millions of customers. It's a huge responsibility. And here's how they think about it. So first, they treat customer data as it's radioactive. Now, this may sound strange. Shouldn't we be protecting data from the people? What does that mean? But this mindset is very important because it recognizes the criticality of the data. We don't want to be exposed to it. We want shielding in place to ensure that we are kept safe from it. So we build a containment unit for the critical data using AWS. We rely heavily in ensuring that the Lumos data, as in other AWS services, as we rely heavily on IAM and network controls, that's what Lumos uses. They use it to build a containment unit out of AWS. They're using IAM, VPC, AWS organizations to ensure that the data is contained. Least privilege is always important, and that there are no cracks in the containment center. I think my clicker stopped working, looks like. So the idea here is it's to ensure that exposure is not even theoretically possible. And as each of these things happen, how we can be using automated reasoning, provable security to really show that the zero trust architecture holds here. Because the idea here is, as I talked earlier, you have the identity-centric controls and you have the network-centric controls. And it's not an or, it's an and. And because we want to make sure that really the data is secure, we are using a combination of both. So here is the universal statement that Amazon Consumer Payments wants to make. We are never unintentionally exposed to customer data. And not now, not ever. And this is where the combination of zero trust architectures and provable security really come into play. And this is a really powerful statement. Imagine if you could go to your management, to your board, and provide an assurance that we will never expose data publicly, or that the backups are completely immutable. That would be very powerful. And I'm going to, as I finish this, I'm actually going to talk about how this can be done. So the first step to that is you have to build a critical zone, the part of the architecture that stores and transmits the critical data. The basic idea is we need to know where the critical data is. So here's a fun analogy. Think of it like a nuclear power plant. We don't just want to know where the radioactive material is, but we also want to know where is the coolant, the control rods, anything else contaminated by the nuclear fuel. We want to know the boundary of the containment system. We also want to know whether it's safe for the engineers to be, where is it safe for them to be, and where it's safe for them to not be. And if Lumos is like a nuclear power plant, then think of the critical zone as the reactor. So let's take a look in action, because I've talked about it a lot. So this is the initial stage of identifying where a critical zone in Lumos is. So Lumos uses tokenization to secure critical data, and the mapping of tokens to critical data is stored in a DynamoDB table. And the table is certainly in our critical zone because this is where all the information is stored. And that becomes the seed of the critical zone. Now we can start asking, who has access to this data? Remember, part of the zero trust architecture, least privilege, least access, dynamic access, those are key parts to achieving a zero trust architecture. So by using IAM policy analysis, and it's the same analysis that underpins IAM Access Analyzer that Nancy mentioned, and based on that, and I'll even tell you a little bit more on how you can be using it, we can determine in Lumos that there is only a single role that has access to the token table, only the tokenization role. Now, we ask ourselves, does this connection carry critical data? Does critical data flow from the token table to the tokenization role? In a sense, is that role exposed to critical data? That's the main question we have at our hand. And the answer is yes, it does. In fact, the whole point of the tokenization role is to read and to write to the tokenization table. So this connection definitely carries critical data. So we add the tokenization role to the critical zone. Okay, we've grown our critical zone now. Are we done? Not quite. So now that we've grown the boundary of the critical zone, and we have to repeat the analysis because we have a new element in our zone. And we can automatically discover, using analysis techniques, all the additional permissions that the tokenization role has. What could it theoretically do with the data? Because we're not only ensured about protecting it as it happens, but we want to make sure that even theoretical protections are in place. And turns out it has many connections. It has connections to logs, your certificate manager, secrets manager, an ECS cluster, and a KMS keys. These are all connections that move out from the tokenization role. Okay, we'll take a look at one of these connections. So this is from the tokenization role to the tokenization metric. The role has the ability to write data to CloudWatch metrics. And so the question is, does it write critical data into the metrics? Are the metrics exposed to critical data? And the answer is no. The connection is only intended to carry non-critical data, just metrics, no specifics. So this indicates to us where controls are needed. And we always have a dual, we have preventative controls and we have detective controls. A preventative control is to avoid the possibility of writing critical data to the metrics, and a detective control is to notify if critical data was ever written into the metrics. We'll take a look at another connection. So this is between the tokenization role and the tokenization ECS cluster. This connection exists because the cluster can assume the tokenization role and the cluster has the tokenization role attached to it. The cluster is where the tokenization actually runs. It's the compute substrate for underneath the role. So we know that this connection does carry critical data. So we add it to our critical zone. And here we repeat the process. Now, we've done a lot of policy analysis, but in the zero trust architecture, the identity-centric controls and the network-centric controls coexist. So we now apply a VPC-based analysis on this Lumos architecture using VPC Network Access Analyzer to figure out who the tokenization cluster can talk to. And we see canaries, other network elements, and more importantly, we see the transmission cluster. And that is the cluster that's actually responsible for establishing a connection to partner banks and transmitting critical data to them when necessary. So we've gone through all these connections, identifying which need controls, which carry critical data, and any that carry critical data are added to the critical zone. And this is how the entire critical zone is mapped out. And now that this thing is mapped out, this new system allows us to ensure where the critical data exists, and it automatically discovers who might be exposed to it. And based on that exposure, there's a decision process. Should we expand our critical zone? Should we prevent or detect any more other exposures through any of the other controls? Or even better, this allows the visibility to Lumos to decide which controls to add in place to disallow connections and reduce the boundary of the critical zone. So I've talked a lot about critical zone because in practice, the critical zones are a small part of the Lumos's AWS architecture. Just like the reactor is only a small part of the nuclear power plant. But it is important to know where it is so that this is the basis of like your zero trust architecture. So now that you know where the critical zone is, you can achieve, and Lumos can achieve, the universal statement that they are never unintentionally exposed to customer data. And that's how Lumos was able to achieve the same trust in their cloud environment as they had in the traditional payment secure zone. And this is where I see the future of Provable Security. It's about making universal statements not just individually about IAM and VPC, but about making universal statements about the most valuable assets in there. So here is the point of like, this is not something that's just specific to Lumos or a handful of customers that AWS has. It really is, we've democratized it. We've democratized it so that it's applicable to all AWS customers. So these are the universal statements that you can be making about the security of your infrastructure. You can say, my S3 buckets are not publicly accessible. You can say, there are no unknown external accesses to my S3 bucket. You can say, all SSH traffic to my instances go through this firewall. So a quick raise of hand. Who's here using Amazon S3 block public access? Great. So this quote here is by you. You are saying, my S3 buckets are not publicly accessible. Now, for the others who are not using it, this one is easy. If you go to the S3 console and look at the permissions of a bucket, you'll see S3 block public access. As the name says, when you turn it on, it blocks public access to the bucket. It mathematically analyzes the S3 bucket policy to see if it grants public access. If it does, it applies an internal lockdown policy to prevent any access from outside your account. And this, in essence, stays into place until you turn it off. And if your policy is not public, then nothing changes. Everything continues as before. Now, you can go broader with block public access. You can enable it at an account level, which applies to every bucket in every region in your account. So when you create new buckets, it will automatically apply to them. It's easy peace of mind. S3 block public access is available at no extra charge, and you should use it liberally. And if you want more fine-grained access control, if you don't want to apply it at account level, you can apply it at the bucket level. Now, as an experiment, let's try to break it. Let's say if we turn on BPA, but then someone tries to change the policy to open up public access. For starters, we will warn them, hey, this is not going to work. Block public is turned on, so don't bother trying anything fishy. But let's say they ignore it and try to do it anyways. the policy attachment will fail. It's a preventative control. It's safe, it's easy, it's declarative. So when S3 public access is turned on, you can't make the bucket public today, and you can't make the bucket public in the future. This is a powerful universal statement. It gives you the bedrock of something you know is true. Show of hands, who's using IAM Access Analyzer? A few, all right. So take a look around. The code is from you folks who are using Access Analyzer. And again, if you're using it, you're able to say something powerful about your security posture. Now, there is no unknown external access to my S3 bucket. This is a much stronger universal statement than the public access one. It's not just saying my house is locked, it's actually tracking down everybody who has a key. To make this universal statement, you can go turn on Access Analyzer, which is available in the IAM console. It is one click to turn on and has no additional cost. When you enable Access Analyzer for your account or your AWS organization, it will give you a list of findings to say who can access your resource from outside your account or organization. And for each category of external access, you will say, here's examples of the findings you see. So here, the first finding says the bucket is writable from an external account. The second finding says the bucket is readable from an external organization. So if we look at this finding, it gives you the details. You can archive the finding if it is intentional, and it just won't show up in your list of active findings again. On the other hand, if the access is not intended, then you need to go remove it. Access Analyzer will direct you to the S3 console for this bucket. You can update the resource policy and change it. Once you've changed the policy, you can hit the rescan button and it will immediately reevaluate it. And Access Analyzer continuously monitors policies for the change. So I could have just waited a few minutes to have the finding update on its own, but I like immediate feedback. So whether marking findings as intentional or by fixing them, the end goal is to get to 0 active findings. 0 active findings means you can state that there is no unintended access to my S3 bucket. That's a powerful universal statement that you can make about the security of your data. You have not just trusted, but verified that there is no unintended access to the data. If you had active findings, the most you can state is, there is no unintended access to my S3 bucket except for these accesses which I haven't quite decided on, but I will someday decide on. Now, that's partial and nowhere is near satisfying. So I don't recommend it. So get to 0 active findings. Have the confidence what is allowed is only what is intended. Now, Access Analyzer is constantly monitoring resource policies for changes. If we want to stay on top of things, we need to know when new accesses are allowed. Sure, we could periodically check the console, but having a more automated approach gives you better mechanisms to ensure that you never miss anything. So shown in this slide is a very simplified architecture to produce email notifications for Access Analyzer findings. Now, Access Analyzer already publishes findings to EventBridge, so you can just wire it up to SNS. Here, I'm going to set up an SNS topic to publish findings, and I'll subscribe to the topic. In fact, I'll subscribe one of my colleagues to this topic so they can be responsible for the new findings. The other step is to set up an EventBridge rule. Here, I create an EventBridge rule that matches Access Analyzer findings, and I'll set the target of the rule to be the SNS topic I just created. It is as easy as it looks. We'll start by changing the bucket policy to grant new access from an external VPC. Within a couple of minutes, Access Analyzer detects this change, it analyzes the new policy and generates a new finding, which shows up in my colleague's email. Zooming in, we can see that this message contains various details on the access. When it's first identified, what actions are allowed, whether it's allowing public access or not. Now, we've talked about things related to identity controls. Here's one more. A show of hands. Who's using VPC Network Access Analyzer? That's okay. This is part of the reason that why we are having this talk. Identity-centric controls and network-centric controls, and ensuring that we want to be able to make powerful universal statements such as all SSH traffic to my instances go through a firewall. Now, let's imagine we want to build a network that looks like this. Here we have two subnets, both fronted by an AWS network firewall. And we can clearly see from the picture, all network traffic goes through the firewall. So we're done, right? Not exactly. This is just a picture. How do we know the picture matches the reality? We don't, which is where Network Access Analyzer comes into play. It's available in the VPC console, which is right next to, actually, if you see, right next to the reachability analyzer. And today we are not talking about it, what reachability analyzer does is, if you can't figure out why can A not talk to B, use reachability analyzer. It's backed by the same mathematical logic as the service we are talking about. But today we are talking about network access analyzer. It's built around this notion of a scope. A scope is a way of saying, show me all paths from A to B that don't go through C. That is our universal statement. We want to see all the paths from the internet gateway to an instance that don't go through a network firewall. Once we've created the scope, then we click Analyze. Clicking this button kicks off an analysis. It looks through all the VPCs to identify every internet gateway, every instance, every path between them, and then filters out the one that goes through the network firewalls. Notice I'm using the word every. That's a key part of universal statements. And it uses clever mathematical logic to do it efficiently and quickly. When the analysis is done, we see a pretty summary of all the paths that match our criteria. Now, turns out we have a single one. This was unexpected. We thought that there would be no ingress paths to avoid the firewall. Looks like we need to investigate. So pulling up the details on the path, we see what hops it goes through, from the internet gateway, through the route table, to the access control list, the security group, and finally the network interface. Clearly, there is no firewall along this path. Now, if we hover over the network interface, we can see the details of the instance it's connected to. Now, this means this is what our actual network looked like. The SSH traffic from the internet gateway to server 3 is routed through a firewall instead of through it. It's around it. So our universal statement doesn't hold. Now, we don't have the time to walk through fixing this firewall, but I think you've gotten the idea now. The important part is, if you know what your network looks like, you can fix it. And once you fix it, you can universally state that there's ingress traffic that doesn't avoid the firewall. But with this network, we can't just do that yet. So I've only scratched the surface of what Network Access Analyzer can do. When you create a scope, there's some suggestions on how to get started. It's a tasting menu of the types of universal statements you can be made. You can make universal statements about ingress, egress, trusted networks, restricted traffic segmentation, or choose your own adventure. Now, if you are serious about knowing the security posture of your network, I strongly encourage you to use Network Access Analyzer. So I'm going to hand it back to Nancy, who's going to talk about how you can be making universal statements about the backup of your data.
Awesome. Thank you so much, Neha. Neha did a great job covering IAM Access Analyzer, Network Access Analyzer, and I'm going to be covering actually another managed solution called AWS Backup. So to start off, with a show of hands, how many of you all here in the audience today are using AWS Backup to protect your data? Awesome. Cool. So quite a significant portion of the audience. And for those of you who haven't yet turned on AWS Backup, I'll walk you through what it does today, how it can help you bolster your ransomware protection. Right? So as we hear throughout all of these events and best practices from CISOs and security experts, often they say backups are the last line of defense. Right? Especially if you consider the, for example, NIST cybersecurity framework, recover is one of the core pillars for a ransomware protection strategy. So to start off, quick intro and overview about AWS Backup for those of you who have not tried the service yet. As of this reInvent, we currently support 17 and counting AWS services. In fact, we just announced coverage for Redshift, as well as public preview for SAP HANA databases running on EC2. So with this wide breadth of coverage, I know, these days with lift and shift to the cloud or cloud native applications, we're not just using one or two AWS services. In fact, many of my actually largest customers are using at least 10, right, if not 15 of AWS services. So with that said, especially if you have that number of different services, plus some customers have thousands of accounts. They're using AWS organizations to manage those accounts. Think of the proliferation of policies that you suddenly have to manage, right? As well as Neha just stated, be able to make universal statements such as, all of my data is protected. Do you really know, right? Especially at that scale? Well, that's actually why we recommend AWS Backup as a managed solution. So this shows the typical backup plan workflow. So a backup plan will consist of policies. And as we talked about in the beginning of our presentation, using tags is really core to our protection strategy because you can simply tag your AWS workloads now across the 17 and counting AWS services that we support, including on-premises VMware as well. Right? You can tag your instances with, hey, with this key value pair, maybe Department Finance or Department HR, right? I want you to protect my EC2 instances that are tagged this way at this frequency and retain it for as long as you want, right? Infinity is also a possibility, right? So with this, and as well as the Vault Lock feature that I just described, so Vault Lock can be enabled at the vault level, right? So what is a vault? A vault at its core is a logical container that contains the secondary copies of your critical workloads. And why this is important is, as I mentioned, Vault Lock was just certified to be CFTC, FINRA, and SEC 17A compliant, which means that no one, not even those with administrator privileges, can go into your vault, delete or mutate your backups. This is super key because I'm sure many boards are now looking at this ransomware event as a solution that they need to present, right? And so being able to state to your board universal statement again, hey, all of my data is protected and it's immutable, right? That's really important to the ransomware protection strategy. So this is a quick workflow of incorporating AWS Backup as a managed service into your AWS environment, such as all of the services that we protect, plus as well as monitoring, right? So it's not just enough to say, hey, I do have tag-based policies set up, but actually, how are your policies performing? Are backups even happening? Are your instances actually protected? And that's why, as part of the Managed Data Protection Suite, we also offer AWS Backup Audit Manager, which is a compliance product to core backup. What that does is it conducts regular monitoring and compliance audits of your backup policies and actual jobs to eventually verify, right, and prove that, hey, you are actually protecting your data according to the regulatory controls and I'm sure, board recommendations of your company. So with that said, just in summary, right, it's not just enough to say, hey, I think this is protected, or I think most of my environment is protected, but we want to show you how and give you the confidence to make these universal statements with, I know without a shadow of a doubt that all of my S3 buckets are not publicly accessible by using Amazon S3 Block Public Access, that all of my EC2 instances are not publicly accessible. And you can do that via Amazon Inspector. And that there's no unknown external access to my S3 buckets. And as Neha mentioned, we can use IAM Access Analyzer to do that. All SSH traffic to my instances go through a firewall, and Neha also demonstrated how we can do that using a VPC Network Access Analyzer today. And finally, as a last line defense against ransomware events, turn on your backups, right? And also one of our launches at this reInvent is the ability to back up an entire CloudFormation stack, as well as all the stateful stores that are in that CloudFormation template. Right? And so that you can be able to say, all of my sensitive and critical data is backed up and also made immutable, protected from malicious actors. So with that said, we'd love to take some questions from the audience, as well as thank you for coming and listening to our talk around Zero Trust on AWS and ransomware protection.